Hello, this is Mustafa Kamaruddin and this is a new recording on data pre-processing. Let's get started. We start by using a dataset from the dataset repository UCI, which is a quite famous repository for finding good datasets. The Bank Marketing Dataset, you can download it using the following link, download data folder. And let's get through the description of this dataset over here. The dataset consists of 4 datasets. The one we are interested in is the bank.csv, which has only 10% of the original data in the full or the complete dataset. We shall use the minimal dataset for testing and applying our techniques, but then for production we shall use the full dataset. The dataset has 41,188 samples and these samples they have two classifications. Either it was successful or not successful, yes or no. That's a binary classification. They have collected data from May 2008 to November 2010 from bank data, where they have made sales marketing calls to different clients, and then they record the duration of the call, the time of the call, some aspects and attributes about each client, and then the final classification, yes, he got the loan or no. It has 16 attributes and the final classification, and these 16 attributes, they are starting from one: age, job, marital status, either married or not, and let's say that these are categorical data. That means they are not numerical data. The education, the balance, and so on. So in this recording we have two goals. We want to eliminate the outliers, and we also want to convert the categorical data to numerical data, and also to find interesting characteristics of this dataset, such as correlation and covariance. So we review some of the techniques commonly used to solve these issues. We start by importing Pandas as PD and NumPy as NP. Then we use the Pandas method read CSV. We give it the location where we have downloaded our dataset of the minimum bank dataset, bank.csv. Let's say that the separator here is a semicolon. Usually the separator is the default comma separator. To inspect our dataset, it's very useful to use on the keyboard the shortcut Shift Enter to run the cells in Jupyter Notebook. So let's inspect the first 5 rows of the dataset. We find here that the age values are numerical, job are categorical, unemployed, services, management, and so on. Marital status, married and single. Education, default whether he has a credit card or not. The balance in the bank. You see some of the data, even though they are numerical, such as balance, but they are not normalized. Normalization is also one of the very useful techniques to make all the data columns or the attributes of the data in our dataset follow a certain standard. That means that all the values are in the range between 0 and 1, or -1 and +1. This is also one of the techniques we'll apply throughout this session. And finally, at the final column, the column number 17, we find why the classification, whether it is no or yes. Just a coincidence that the first 5 columns here have got no as response. Another useful method in Pandas is df.tail, which shows the last 5 rows. To manipulate the rows in the Pandas data frame, there are quite useful methods such as apply, which applies a lambda function or a predefined function to every row in the dataset. So how does this work? We start by saying that data frame of material, this column, equals a data frame of material after we apply the replace material function we have defined over here. But then it's quite notable that we have to apply this method across the column of every row and not the other way around. If you say 0, it will apply it across the columns. If you say 1, it applies it across the rows, which is desirable in this case. If the value equals single, then we return 0, else he's married, we return 1. Shift enter to run this code cell, and let's inspect our data and how it looks like. Now in marital, we have replaced married and single with ones and zeros. We shall do the same for housing, but using a different method. So instead of using apply, there is also another method in our toolkit or in our arsenal, that's map. Map will take a dictionary as an argument with keys as no and yes, and the values to be replaced with as 0 and 1, and the rest is the same as apply. We run the method, inspect our data, we find that housing now is also okay. Let's restart our kernel. Maybe it's reading data from a previous run. So it shall start all the columns, all the cells in the Jupyter notebook. Let's scroll back. We have replaced the housing, and here we are. And the same for data frame.tail. We shall do the same for loan, but using a different method. So this is the third way of doing this. There are 3 ways to do the same thing. This gives us a lot of flexibility on how to handle our data. The final metric in determining which the method to use is of course the time benchmark, which is faster in terms of runtime. Replace takes also dictionary and replaces the loan in case of no with 0 and case of yes with 1. It's always convenient when working with machine learning algorithms to work with numerical data instead of categorical data. So now housing, marital status and loans, they are all numerical. See the last 5 columns, we get something like this. Now let's turn to something more interesting. Now we see that the job, it has different values, but we can't really know which are the actual values. So we'll use data frame of job dot unique. This will give us all the unique values that happen in this column. We find that there are some values like unemployed, services, management, blue collar, self-employed, technician, entrepreneur, admin, student, and so on. We build a dictionary, and here it's, let's say, unknown. The key of unknown will be replaced with numpy.nan or not a number. This makes it easier later when we are eliminating the missing values. One of the things that quite often happen when pre-processing machine learning datasets is that you find a lot of missing values that hadn't been correctly collected. In this case, when they are their values are not a number or nan or just null, in case of Python that is none, you replace nan and drop all the rows where nan occurs. This is quite a common technique for handling missing data. To make things more interesting, we say that in-place equals true. That means without copying the data frame all over again, it just replaces the value in the old data frame. We call head and tail to inspect the new results. We find that the job now has some numerical data. We do the same for education. We get the unique values for that column, replace the unknown with numpy not a number, and the rest with numerical values in place to avoid copying. Now we see education has been converted from categorical data to numerical data. Let's do the same for default, which means whether he has a credit card or not. Of course, we get this interpretation from the description of the dataset. Here you find default has credit card in default binary yes or no. Inspect the head, default 0, inspect the tail, we can see 1 over here. One of the quite standardization or normalization techniques is called min-max technique. That brings the minimum value in a column, the maximum value, and then for every value, it brings that value to some relative value in between the minimum and maximum. It's quite a very simple equation. That's, let's say the value is x, that will be the new x will equal the old x minus the minimum value divided by the maximum value minus the minimum value. This is quite commonly used standardization technique, and you'll find it a whole lot useful when working with machine learning. So in Pandas we use data frame of column balance dot minimum to get the minimum value, data frame of column balance dot maximum to get the maximum value, in this case 71,188, and then we call the apply method on data frame of balance with a lambda function, lambda of v. That means for every row in this with this column value v, we apply the formula v minus minimum divided by maximum minus minimum. Let's inspect the data frame now, how it looks like. Remember, we have been working on balance, so you can see balance now has been given values between 0 and 1. You can see over here between 0 and 1. We replace the contact data again with the numpy dot not a number, telephone with 0, cellular 1 in place to avoid copying, and now it looks like this. When we say contact.unique, we'll make sure that there are unique values 1, none, and 0. We do the same for months. We get the unique months, apply a map function, and note with map we have to do copying, replacing all the string values with numerical values. Do the same again for the previous outcome. What was the outcome of the previous call, whether it was a known, failure, or success, or something else. Inspect our data. We find that we've got name, not a number, 0, and so on. Finally, the final binary classification, we replace the no with 0, the yes with 1 in place to avoid copying. Get our head, and we see most of the cases were negative or with 0 outcome. But just to confirm and be sure that our apply method or mapping method worked correctly, we get the unique values on the data frame of y to find that there are yes 2 values 0 and 1. We have forgot to normalize the duration. Over here the duration of the last call may be in minutes, so we apply df of duration dot apply lambda function of v minus minimum duration over divided by maximum duration minus minimum duration. We do data frame dot head, get the first 5 columns, Another useful method to get some statistical description of our dataset is to use pandas data frame.describe. In this case, it counts it counts the rows which doesn't have a null value or not a number value. In our case, age has got 4521 rows with the real values. The job has got less values since we have replaced the unknown with the not a number. 4521 seems to be the number of the rows overall, but in cases where we have replaced the unknown with not a number, we get lower values. Then different statistics like the mean, the average age of the ages we've got are 41. Of course, for this job it doesn't make much sense as we have already replaced the categorical data with numerical data. But for the balance, for example, we get that the mean is 0.06 and the duration should also make sense to us. The duration is 0.08, which is quite long, like 80% of the maximum duration value. And the standard deviation, that means the values around the mean. So we find that the standard deviation in case of the age is 10. That means most of the values, they are either 31 to 51. These are people of these ages have been conducted reported in this survey. The minimum, the percentiles, which is quite useful to understand the distribution of the data in order to eliminate the outliers. This would be quite useful next. 25% of the people in this survey are above or equal 33 years old. 50% are above 39. 75% of the samples in this dataset are above 49 years old. The maximum age is 87 years old. And the same for the rest of the columns. Having replaced the unknown values and the missing values with not a number or numpy.nan, then we have to save our dataset. We call pandas dataframe.tocsv the new file name, and the index equals false, and the index in this case is this column which has the ID or the identifier of every row. We don't want to save the index. We read the file using pandas.readcsv without specifying the delimiter. Now it is the default comma delimiter into a new data frame. The new data frame.head first 5 rows. It gives us the data that we have saved. Next, we want to find the correlation between the attributes and the final response. We want to know which one most likely influence the final response. If it's the age, the correlation can easily be calculated using pandas data framework dataframe.correlation. The method calculates a correlation between every 2 columns in the dataset. We are mainly interested in the Y correlation with every other attribute. The correlation between every column and itself is 1. This is the maximum value of correlation. They are strongly influenced by each other. A negative value means a negative correlation. That means if there is a negative correlation between housing and balance, it means if the balance is high, the housing gets a low value. If the housing is high, is low value. If the balance is low, then the housing will get a high value. An inverse relation denoted by negative value here. A0 which doesn't quite happen here, but a zero correlation means there are no influence direct relation between the two attributes. We can find from these calculations that there is a high correlation between the previous outcome and the final response, a quite high correlation between the previous contact, whether it has been contacted or not, and the final response. When he was contacted in the previous days, the duration also has got a very high correlation, 0.4. The rest is you have got lower values for the correlation between the response and the direct attributes. Next we import matplotlib.pyplot as plt. That will help us plot some diagrams. In order to make this work inside the Jupyter notebook, we have to call this directive matplotlib space inline. In order to draw the heat map of this correlation, we use matShow or matrix show of the new dataframe.correlation using a color map or hot color map like summer to give us bright contrast colors, and we draw the color bars to tell us which color corresponds to each value. Next we say the plot x text, that's for the labels on the x axis. They range from 0 to the length of the columns of this data frame, in this case 16, so this will range between 0 and 15, and the values will come from the data frame.columns, and these are the names of the columns, and the rotation will be vertical so that they don't jam beside each other, so we can see them just like the way they are now. We do the same for the y text, but this time they are horizontal, and then we say plot.show. A high correlation of 1 is denoted by yellow color, a very low correlation by a darker green color. Here along the diagonal we can see that there is a very strong correlation between every attribute and itself. We can also see that there is a high correlation between y and the duration, the previous outcomes, previous days, and whether he was contacted previously or not. Not so strong correlation with the other attributes, maybe the age, but not quite notable in here. We can also call the data frame method sort values, which helps us get more sorted values of this correlation matrix using ascending equals false, so that to get the higher values first. And here we are only interested in the correlation with the response y. Very strong correlation with itself, duration as has been interpreted from the diagram, the previous outcome, previous calls, previous days, age, months, and balance. These are the ones that have higher correlation with the response. The job, the default, the contact, the day, the marital states don't have as high correlation. Housing has got an inverse correlation with the outcome. So to find outliers, one of the very useful tools in our arsenal are the box plots. The box plots simply shows us a box around the where most of the values are located, like if 50% of the values they are located between the value negative 0.5 and plus 0.5 in a visual manner that help us eliminate the outliers. So dataframe.plot.box will simply plot the plot box diagram box plot diagram. We replace the x text with the range of the number of columns and the values of the names of the columns, rotation vertical, so that we can visualize the outcome. We can see here that the previous outcome in previous days, they have got a large number of outliers, but most notably with age, there are more outliers with age that are worth inspection. Also note that the previous days previous outcome, they have been converted from, especially previous outcome has been converted from categorical to numerical data, so these outliers don't really shouldn't be really interpreted, as it doesn't really mean an outlier. But here in the case of previous days, it has not been normalized and it has not been converted, it has always been numerical, so there is also high number of outliers with this previous days. Of course, we want to remove our outliers from the dataset because this will influence the learning process later and will cause our learning algorithm to be biased towards some values. So let's plot the ages value. We can plot single column by plot data frame.age.values. We get something like this for the 4000 plus something, ranges of ages between 0 and 90. Mostly they are between 30 and 60, but some values go up higher to 70 and 80. To visualize this in an even better way, we plot the histogram, which shows here clearly that the values are centered around 35, most of them between 20 and 65 maybe, but then some outliers between 70 and 90. One of the other useful techniques is the covariance matrix or the scatter matrix. Here we have the scatter matrix, of course very small. We have to redraw again using a figure size parameter. Pandas has got its plotting library. We import from Pandas plotting scatter matrix. On the data frame we have got alpha 0.2 for transparency, the figure size 12 by 12, and diagonal equals KDE for the distribution with itself. Here we've got all the scatter covariance matrix of all the attributes with each other. Of course, we are always interested between the covariance between the response and the other attributes. Unfortunately, in this case of this dataset, it didn't say much about the covariance between the data and each other. We couldn't really make a useful interpretation out of this. They are either 0 or 1, regardless of the values. We can't really figure out a pattern in here, but it's quite useful to have this tool which you can always throw at problems as they arise. Dataframe.plot will give us a plot like this, where it plots all the rows in the dataset against the values they range from. Of course, we can see here that some values are not normalized, especially the age. We should have normalized the age in case of a real life problem. Next, we have figured out that there are some outliers with age and duration or previous days. So let's get rid of them. This is how to get rid of them. Let's say we want to get rid of the first 1% of the age, or other 100ths of percent, and then the other high end 1% near the other end. So if we imagine that we have a range of between 0 and 100, that's 100%. Some of the data, we get rid of the first lower 1% of the data, and the highest end another 1% of the data, and we hope that will help us eliminate the outliers. We call the function quantile on pandas data frame.quantile, giving it a list between low and high, and this is the output for every column. We get to know which are the value below which are 1% of our data. In our case is 24 years old for age, and then the other 99% are below 72 years old. The duration should be something similar between 0.002 and 0.4. The balance also is interesting in this case. The other categorical data don't really make a lot of sense in this case. Then, having saved our quantiles data frame, we say quantiles data frame.age. We get that 1% 24 years old, 99% 72 years old. This is how to index this lower end value. We say quantile data frame.age of low, which is 0.01, give us 24 years old. We'll use this value for eliminating the outliers using the apply method on the data frame.age. We apply a lambda function that takes as a parameter v, and we say that if the value is between the 24 years old and 70 years old, we keep the value as is, which is v. Otherwise, we replace it with numpy dot not a number. Let's describe our data. We note here that the age where the values are not a number or are a number has dropped from 451 to 4406, and the mean has shifted as well, and the standard deviation. The minimum now has become 25 and the maximum 71. This has eliminated some of the outliers in our dataset. We could have been more rigorous and tried more rigorous boundaries. Instead of 0.01, we could have eliminated 0.1, which is the lower 10%, and the higher 10% with 0.9 instead of 0.99, and so on. So we need now to get rid of this not a number rows, or rows where age is not a number. Very simple. We use dataframe.age.drop not a number, or drop na not available, and in place equals true to avoid outliers. We describe the data. We find everything is as is for these age columns, but then we were list our columns. We get the heads, first 5 columns, the ages are in the range specified. When we get the unique values, we don't find nan anymore or not a number anymore. They are all numerical values. When we draw our plot box, we can see here there is only one case where the age is 71, and the rest they are all within the boundary of 33 to 50 or 49. So this shows us how to get rid of outliers using Pandas and Matplotlib. Hope this was quite useful. Let's carry on. Similar to correlation but with different interpretation is the covariance, calculated with dataframe.cov or the covariance method. Instead of having values unlimited like 1 and so on in case of strong correlation, and negative values in case of negative correlation, they are strictly between +1 and -1, which is quite a standardized method for interpreting correlation. So covariance is also another way of seeing how correlated the data with each other, but with more standardized values. Of course, covariance between every other two elements and themselves is quite high, or the opposite, quite low. But then we are only interested in the covariance between the response and every attribute in the data. The B outcome is still with a high covariance. Previous days have gone to very low value. The balance have gone far, and so on. It's quite interesting to understand how your dataset attributes are behaving with each other and so on. We save our pre-processed dataset once again to our using Pandas 2CSV file using index equals false to avoid printing or saving the column with the numerical identifier for each row. We are quite done. However, let's discover a few more techniques to show the patterns in our dataset, like Andrews curves. Andrews curves, they plot the data according to the classes they belong to. In case of 2 or 3 attributes, this would have been quite meaningful, but in case of our very covariant attributes, this doesn't make a lot of sense, but still shows another tool where you're having a dark gray for 0 and the rest light gray for 1, and it shows how the data are segmented around the values of the attributes. We could also have used the plot with subplots equal true and the figure size 16 by 16 to get individual plots of the data to get the ranges of values for each of these subplots as seen here. Similar to Andrews curves are parallel coordinates, which also shows the same thing, how the data are how the samples are segmented around the values of the columns. Here we have got light gray for 1 and blue for 0. The histogram for the balance shows that most of the balance is centered around the low end values, and of course this would have been a good candidate for eliminating outliers. We see here the response is only 0 and 1, confirming that we have not tampered with our data. The density function also shows us about the barrier probability distribution of the data. We try to find the patterns here. Maybe some of the data follows a normal distribution, like campaign. You can see that is slightly following a normal distribution. So in case of a classifier like the Bayesian classifier, knowing this barrier data would have been helpful to get a mu and sigma around this data. The same for the previous, but for the rest we can find a pattern for a known data distribution that we are accustomed to. The histogram also shows how the data are distributed with different values. You can see there are some more variance with the age, with the duration, but the rest they are most likely centered around zeros and ones since they are categorical data converted. Okay, that's for today. Thank you for watching and see you next time.